Yeah, you can keep it in milliliters because you're dividing by milliliters again. So that's why you don't have to change it. It would basically be like you'd be dividing by 1,000 and then multiplying by 1,000 again. So, yeah, so you don't have to worry about it. Okay, let me give everybody a minute to make sure you're up to speed with the dilution, and then we'll look at what the actual equation is. So this is dilution step. Okay, are we okay with these values? All right, so dilution step, every time I say so let me just show you the document I'm working on. So someone said, like, how do we know which calculation we're supposed to be using? And I was like, oh, right. So it's not just the calculations people are getting stuck on. It's like they know how to do the calculations. They're just not sure how to figure out which one they need to do. So I'm going to make this into something that's easier to send out as a PDF or post on Blackboard, rather. But I've realized that everything in chapter 17 and 18 can kind of, all the calculations, not the concepts obviously, but all the calculations can be summarized by basically saying, sometimes the questions don't always ask for pH, right? So it's going to be a variation on this. But if they're asking for pH, we can summarize, are you talking about just one chemical, okay? If you're talking about a strong acid or a strong base, those are really straightforward calculations. If it's a strong acid, you just take the negative log of that, right? If they say it's 0.2 molar HNO3, you don't have to do any ice table because it's HNO3, it's a strong acid. All of that will turn into H+, H3O+. So you just take the negative log of 0.2. If it's a strong base, it's really similar to that, but now that's OH minus. So you can take the negative log of, let's say it's 0.15 NaOH. You can take the negative log of the 0.15. That just gives you POH. So you have to subtract it from 14. Realize I'm going to put in there like what calculation I would typically use, but there are other ones. For this one, you could do the H3O plus times OH minus is 1 times 10 to the negative 14th, and then take the negative log, that's fine. But I'm just trying to get at the fact that these two are very straightforward, right? If you have one chemical and it's a strong acid or strong base. And maybe what I'll do is like put in that little circular calculation thing in that spot. If it's a weak acid or a weak base, that's when you use a standard ice table. So just one step, you don't have to like do a consumption step or dilution or anything because it's just one chemical. You do an ice table, and then either, if it's an acid, you get the H3O plus and take the negative log. If it's a base, then you do the POH, and then do 14 minus that, okay? So that's like really the vast majority of the calculations in chapter 17. Chapter 18, let's see, what we just did was weak acid, what did we just do? Strong acid with a buffer, okay? So that would be this one, but I haven't finished it quite yet. So this should be weak base or a buffer solution, okay? So anytime you have two chemicals, you're going to come over and kind of figure out which one is it. In this case, you have a weak base plus a strong acid. So this is where you're going to go through, like, I got to do a dilution step because I have two chemicals now. I really am going to make this a little bit more of a flow chart when I get a minute to do it and actually think through it. This was just an idea that someone brought up in my first class, so it's a very rough draft. So every time you're mixing two chemicals, you're probably going to have to do a dilution step. So like that's a good one. It's like, is it two chemicals? Do a dilution first, then think about what are the type of chemicals, and I'll walk you through. So then we do the consumption step, which is where we're going to use up all of either the strong acid or the strong base. So in this example, we're starting with a strong acid mixed with a buffer solution. So this is a good reminder that if you're adding a strong acid, even if it's a buffer solution, you better write the reaction adding it to the base, the conjugate base, whatever. So that's why it says A minus plus H plus. So let's go back to our problem that we're working on. Okay, so it's a strong acid. So for the equation, I'm going to write A minus, the conjugate base, plus the strong acid. Now, you can write this as HCl if you want. You can write it as H plus. You can write it as H3O plus. It doesn't really matter. I'll just leave it as HCl to keep it simple. Because in the end, all we really care about is how much of this do I have and how much of that do I have by the time I get to the end. So whether I write it as HCl or H plus is irrelevant. I don't even need to write the water if I, use H3O plus. I don't need to write that on the other side. Okay, so I've got the equation. I knew to use the base because I was adding acid. I always have to have an acid and a base. If I'm doing, which the next problem we'll do is this, if I add a base, I need to mix that with the acid. Okay, so now I'm going to do the consumption step. I don't like that I call this final because it's not actually the final. It's like the almost there before we do the equilibrium, but this is how I've done it. So it's like an ice table. The difference is you know what the change is here. So let's put in those values that we just did, those new diluted values. And then I want you guys to take a look at this, go back to Friday's notes if you need to, and do the consumption step, meaning we're going to consume all of that strong acid, followed by the equilibrium step, which is the Henderson-Hasselbalch equation. Dilution, consumption, equilibrium. When you're mixing two chemicals, that is a very common formula for how you're going to approach the calculation. Okay, if you're doing good, don't bother looking up. If you need to check that next step, the consumption step, feel free. Wait, I swear that was negative. Maybe that's the other 177. Oh, I put them in the wrong spots. That's why. Okay, so this is a great example. This is super common that like you get mixed up about what's where, okay? So base on top, so that's the thing that is missing the hydrogen, remember? I remembered from my last class that this one was negative, and then I didn't get it negative, and I was like, what? It still doesn't look right to me, but I also get mushed up with all the different problems after a while. No, it looks okay. Okay, what clarifications do we need? Where are we getting stuck with these? When I send you this document, I'm gonna have like, do an ice table, do a dilution step, do the Henderson-Hasselbalch equation. That's what this one is, okay? I want you to feel comfortable when I say those terms as to like what part of the calculation that is. I would say the consumption step is the one people are least familiar with because you have to come up with the equation and you have to remember that the change is not an X. It's not something we don't know. It's like you're using up all of that strong acid or the strong base, okay? So that's why I subtracted all of this. Whatever that number is, I just subtract that. Subtract it from the other reactant and I add it to the product. So figuring out the equation, if it's an acid, mix it with the conjugate base. If it's a base, we'll do that one next, mix it with the conjugate acid. And then make the other one on the other side. Then when you get those numbers, make sure you plug them into the right spot. And that's your equilibrium step. So dilution, consumption, equilibrium. The thing that's cool about this is that we actually, right now, have done all of the different calculation types that we need to for the entire thing. So, couple quick notes. Well, not quick, but... So like I said, we've done all the calculations now. We are going to start in on titrations today, which you guys have done one of those in lab already. So I think you're familiar with like the rough methodology of what you're doing. We just need to go through the calculations in detail. But the nice thing is this is part of the calculation. Even though these are technically buffer calculations, when you titrate a weak acid, you actually create a buffer. And so the calculations that are after the beginning but before you get to the end point or the equivalence point, those are really the same as buffer calculations, okay? Because of that, I realized that we really don't need the entire week to finish half of chapter 18. So if you're looking through like your reading, we only go up to 18.4 in 18, okay? So we're gonna finish off buffers. We have one more problem to do with a base. Then we're gonna start in on titrations, and then we're gonna continue titrations on Wednesday. And I have decided we're going to move the test out of finals week and just put it on Monday, because there's no reason we need to have 3 classes on this plus a review on Monday. So sorry if that's like not helpful. I think for some people it is helpful, because then you can kind of like finish out chemistry and focus on everything else. So it is not a final exam, it's just test 4. So that'll be in class on Monday, which means that new material will be done Wednesday, review on Friday, and then test on Monday. I'm not gonna change the homework for 18 just because, I don't know, too many people are like, I have this and I have that and whatever. Just please remember, if this was like a normal schedule, I would make you have chapter 18 homework due on Thursday night. So like that's what you should try to plan on, okay? You have more than enough information to do the first half of chapter 18 homework before Wednesday. So anything that's talking about buffers, you can do that by tomorrow night. And then anything that's talking about titrations, you can do by Thursday night. Okay? So that would be my preference for you. Okay. So I will recap that schedule in an email this afternoon, as well as letting you know that I posted that decision tree in a nice readable format. And then just keep practicing. Like that's all we really need to do. We've learned all of the calculations. We just need to practice them this week. Yeah. No, somebody else asked that too. I was like, no. What I would recommend though is use it alongside your exam equation sheet, because the equations are on there. And if you kind of like do your practice problems with both of those, it'll create like a mental picture of like, this is the equation I need to go look for, and here's the spot where it is on the exam equation sheet. Yeah. Okay, so one last practice problem that's just buffers themselves. This one is now with a base, okay? The dilution part is actually, if anything, a little easier, because you're not really diluting it. You're not adding a volume. You do need to calculate the molarity of the NaOH. Okay, but this time we're adding a base now to a buffer rather than adding an acid. Same 3 steps: dilution, consumption, equilibrium.
So you get the polarity of the electron divided this. It's what amperes. And then the IC, except this time you're subtracting, like the amount of NaOH you get is what you subtract from these two. And then
For this one, I'm going to go ahead and write the equation first and then do the dilution like as part of that. I just think it's faster. So because it's a base, we're adding it to the acid. Don't worry if your equation doesn't look perfect. The key points are that you have the right two chemicals together, okay? If you write it as OH minus, or if you like don't write the water on the other side, that's fine. You just need to make sure if it's a base, you're adding it to the acid. If it's an acid, you're adding it to the base. Okay, if you're following along, I'm moving on to the consumption step now. And last, the equilibrium step. Okay, is this starting to feel a little bit more like, what's the word? Like you're doing the same thing over and over again. You just have to like identify which kind it is. I hope so. Okay. These are very similar to what we'll do on Wednesday. when we get to we'll just do weak acids, I think, with a strong base for the titrations. So this will look really similar to what we do on Wednesday. So what we'll do for the rest of today is do kind of the easier titrations, which are strong acid with a strong base. So keep in mind, if we go back to that, rough draft I've got here, a strong acid plus a strong base, there's no equilibrium there because everything goes to completion. So we'll still do a dilution step and we'll still do a consumption step, but then we'll just take whichever one's left, like an acid or a base, and do negative log of the H plus if it's the acid, or 14 minus the negative log of the OH minus if it's a base. Okay, so there's no equilibrium step with strong acid, strong base mixtures. Okay, hopefully this looks familiar from when you guys did it in lab. Titrations, you start with either the acid or base in the flask, and then you add acid or base to it. I'll talk about it in terms of how they have this picture. So the acid is in the flask, and we're adding the base. Every little molecule of base that you react or that you put in there neutralizes one of the molecules of acid. So like this one, they have 5 molecules of the acid. You add in 2 bases, and they create water. You've neutralized these now, and you've got like 3 left over. So we can calculate the pH before we add any base. We can calculate the pH once we've neutralized some of the acid by adding base. And then we can also look at the pH at the equivalence point. When you're doing a strong acid and strong base, that's just 7. You've neutralized everything. Because when we say equivalence point, we mean like however much acid you have, you've added that much base now. So right here, equivalence point, moles of acid are equal to the moles of base. So if we start with 0.1 molar acid and 0.1 molar base, when we add the same volume, that's when they'll be equal to each other. The pH calculation, though, is like super easy because they're strong acid, strong base. They just neutralize each other. It's 7, always 7. When we get into weak acids, then we'll have to actually calculate it. Okay, so we're going to do the first few for strong acid, strong base today. So we'll come back to this. Okay, I don't actually want to, let's just highlight the ones we're going to do right now. So we're going to look at what about before you start the titration at all. And then once you've added a little bit, but not enough to get you to the equivalence point. Okay, that's the 2 we're going to do. And then, like I said, at the equivalence point, that's equal to 7. Okay, consider the titration of a 25 ml sample of 0.22 molar nitric acid. So I'm going to go ahead and draw our little picture here. So we've got 25 mils of 0.22 molar HNO3. And we're going to add 0.13 molar NaOH. And at the beginning, we're going to look at it before we've added any NaOH. So ignore this for now. We're just going to look at that solution first. At the very beginning of chapter 17, we said if you have a strong acid, you just take that to be equal to the molarity of the H3O plus. So you just take the negative log of that. Okay, pH is the negative log of the H3O plus. And for a strong acid, H3O plus equals that molarity. So that's literally it. For a strong acid, strong base titration, you just take the negative log. So negative log of 0.22, the pH is 0.66. Done. So when you're looking at this decision chart, decision tree, it says calculate the pH before any NaOH has been added. Okay, this is not a combo one. This is not two compounds. This is just one compound. There's nothing else in there right now. There's just the strong acid. So when you look at that, don't get confused by the fact that it says we're going to be adding NaOH. We haven't added it yet. So go to one compound, strong acid. Okay, I'm just going to take the negative log of that. I'm just going to calculate a really simple pH calculation. All right, second step, calculate the pH after the addition of 18 mils of 0.13 molar. Okay, so adding to our picture, we're adding 18 mils of this. All right, we are going to do a dilution step. We have two compounds now. Anytime you have two compounds, you're going to do a dilution step. I just jotted that in the notes right now. Two compounds, do a dilution step first. Then we're going to do a consumption step, but we do not have to do an equilibrium step because it's a strong acid and a strong base. Okay, so go ahead and take a shot at this. However you want to write the equation is fine. You might see in your book just H plus OH minus. That's fine. I'm going to write it as the full compounds. But like the products don't even matter in this. Just realized what we could do is like on Friday, we can do a sample problem for every single type of these calculations. It'd be a good way to organize it, but I'll mix them up so you have to figure it out. Okay, double check your molarities in that dilution step so that you know you're starting with the right thing. All right, so again, strong acid, strong base. You're mixing two chemicals, you better do a dilution step. Okay, so do the dilution step. I'm trying to think if there's an example. The only time you don't do a consumption step is if it's a acid and its conjugate base. Okay, there's no strong acid or strong base being added. That would be the only time you don't do a consumption step. So consumption step, you use up all of the smallest one so that there's no NaOH left over. How did I pick which one? Why are you guys all packing up? We still have like 5 minutes, don't we? We have 2 minutes. Okay, stop it. So we use up all of the NaOH because that's the smallest amount. If the acid had been the smallest amount, we would use all of that up. Okay? Then we look at what we're left with. We're left with the acid, so we just take the negative log of that. If we were left with the base, we would take the negative log and then subtract that from 14. Okay, so we'll finish these up. We'll do weak acid with strong base on Wednesday and then start our practice stuff. Today's Monday, right? Let me stop recording this before I forget.